Hello students. So in this assignment, we begin with a distance time graph, which shows the movement of an object that is not specified, but it's not important in terms of our mathematics. So the first question asks us for the speed of the first 3 seconds. So as you can see, the first 3 seconds, the distance is increasing, then followed by the total distance, followed by the average speed. So how do we go about handling this question, right? So let's begin. So to find the speed, okay, for the first 3 seconds, we need to understand that for a distance time graph, the gradient of the graph represents the speed, right? So to find the gradient of the first 3 seconds, we'll find the rise over run. So in this case, the rise over here is 20 minus 5. So that's in the numerator. The denominator is 3 seconds minus 0 seconds. So that gives us 3. Right? You can also use the formula for gradient in a Cartesian plane to actually calculate this. So that works out to 5 meters per second. So for part B, we are now told to find the total distance. So the total distance, we just need to examine carefully. We start at this position, right? 5 meters from the point of reference. The point of reference will be the origin, right? So from here up to 20 meters, so that's 15 meters traveled. And then on the return journey from 20 to 0, so that's 20 meters traveled. So total distance traveled is actually 15 plus 20. That gives us 35 meters. Okay. Finally, average speed, we need to remember that average speed is total distance divided by total time, right? So the total distance is our answer for part B, which is 35. And the total time taken is, well, 10 seconds, right? We can read that off the graph directly. Therefore, the average speed is 35 over 10. That gives us 3.5 meters per second. Okay, moving on to the next question. Here we have a scenario, right? A man left his home at 1400, that will be 2 p.m., okay, to pick his daughter from school. On the way home, he stopped at a petrol station to refill his petrol, right? So the graph actually describe what happened, right? So the question goes, okay, what was his speed in kilometer per hour on the way to school? So as you can see from the graph, right, the units is actually kilometers for the distance and minutes for the time. So we need to convert the minutes to hours. Okay, so how do we do that? Well, so we begin by observing the journey. Okay, for the first portion here, you'll find that from the home to the school, which is 10 kilometers. So you travel 10 kilometers for the first line on the graph. And the time taken is actually 20 minutes. Okay, so to get the units that's required of the question, we convert 20 minutes to 1/3 hour. So 10 kilometers over 1/3 hour will give us 30 kilometers per hour. So that's the speed at which he's traveling to the school of his daughter, right? So part B, we are asked at what time did he leave the school? So you can see he actually traveled, okay, from 0 to 20 minutes he traveled to the school. He actually stayed there from 20 to 30, right? So he actually waited 10 minutes for his daughter over there. So the time he leave the school, okay, that will be 30 minutes from the beginning time, right? So the beginning time, the starting time is actually 2 p.m. So that will give us 2:30 p.m. Okay, so you write it in terms of the 24 hours format. It is 14:30 hours, right? So part C, how long was he at the petrol station? Well, let's observe. So the first time the graph is flat was where he's waiting for his daughter. The second time where the graph is flat, that's where he was actually stationary, not moving at the petrol station. And the time taken there was, okay, that will be 5 minutes, right? So from 40 to 45, that's 5 minutes. Okay. Part D, we are asked to calculate the speed in kilometer per hours on the way home from the petrol station. So that will be the last line of the graph, okay, the one that goes from petrol station at 45 minutes to 55 minutes, right? So the speed at which he's traveling, okay, let's check. The speed in this case is the gradient, right? So the gradient of a distance time graph. So what's the gradient here? Well, the gradient, the rise is over here, the vertical distance, the rise, that will be 7 kilometers, right? And the run is actually from 45 to 55, that's 10 minutes, right? So the speed will be, okay, 7 kilometers over 10 minutes, rise over run. We want the units, okay, in kilometer per hour. So 10 minutes is 1/6 hour. That works out to 7 divided by 1/6 equals 42 kilometer per hour, right? And finally, the average speed of the entire journey. Okay, so we need to figure out how much he traveled total, right? So he traveled 10 kilometers. After that, 10 kilometers back. Okay, so total distance covered is about 20 kilometers, 10 plus 10. And the total time is 55 minutes. So 20 kilometers divided by 55 minutes, convert 55 minutes to 55 over 60 hours. We end up with 21 and 9 over 11 kilometers per hour. All right, so that is how we can actually answer questions with regards to distance time graph. Have a nice day.